Welcome to Calf Academy, your source for calf care education.
This section will talk about whole milk and waste milk feeding. So in this section, we'll talk about the pros and cons of liquid feeding options, the distinction between feeding whole milk versus milk replacer, what we look at from a nutritional consideration, and from a biosecurity or disease standpoint. And then we'll look at whole milk feeding options in regards to pasteurization, and we'll touch on economics. There are a lot of advantages to feed whole milk. It's obviously a high quality liquid feed. It comes straight from mother herself. We know it's high in fat, high in protein versus a typical conventional milk replacer. It's usually around 3.8% fat, 3.1% protein. Of course, that varies by farm and by cow. But on a dry matter basis, that would be roughly 30% fat and 25% protein. So to get at the dry matter basis, you just simply divide the fat and protein tests that you'd get from the lab, from the creamery, and divide it by the total solids that are in the whole milk. And that will get it to you by the dry matter basis. Whole milk, especially with saleable milk, is typically more expensive than using milk replacer. So a rule of thumb, we can take the mailbox price of milk, times it by 4, and that's the price you'd pay for 50 pounds of dry milk replacer. So the example would be a $60 hundredweight mailbox price times 4 would be $64. That's the amount of dry matter in 400 pounds of liquid milk. So 400 pounds of liquid milk times 12.5% solids equals 50 pounds of dry matter. So you can easily do the math on that. So in contrast to whole milk, waste milk can be extremely variable. However, waste milk could be a valuable commodity to feed to calves if it's handled properly. It clearly has some disadvantages. High bacteria counts potentially can introduce pathogens to calves. The nutrient composition can be fairly inconsistent from day to day even. And of course, the supply of hospital milk can vary considerably from day to day. There's always the question about antibiotic residues that would be in the waste milk. We clearly need to have a discussion about pasteurizing that waste milk if it's going to be fed to calves. And of course, if you've got enough waste milk that you've got plenty of it to feed all your calves, that's kind of an indication of maybe you've got some other issues in the herd that need to be examined. So Bob James from Virginia Tech had looked at quality of milk coming in from various parts of the U.S. For example, there is shown in this slide the plate counts from the east, from the west, and from Wisconsin. And you can see the variation between low and high, and all parts of the country are pretty significant. In the high counts, of course, when you start looking up into the millions and billions, it's extremely risky to feed that kind of milk to calves. In the same way, when we looked at fat percent and protein percent, Dr. James showed there was a considerable range there, except for the example of the fat percent in the west, all the way from 1.2% up to as high as 12.1%. So those are some examples of the variation you can see in the different types of quality that you can see in different types of operations across the whole country. So while whole milk is higher in fat and protein than a typical milk replacer, whole milk does not have all of the necessary minerals and vitamins that a calf would need. Oftentimes, producers will say calves just gain more on whole milk. Well, we got to make sure we compare the nutrients in whole milk compared to what would be in most milk replacers. Oftentimes, whole milk has a more dense nutrient profile than what you'd find in milk replacers. So we got to make sure we compare the right things. However, whole milk, as we've seen in the chart from Bob James, whole milk can be very high in fat. And higher fat diets tend to produce less lean gain, less structural growth. High fat diets will delay starter intake, and oftentimes that results in a weaning age that's going to be later than maybe what the dairy is comfortable with. Most likely because we got to feed milk for a longer period of time. There's more labor, more individual care, and just more time in the hutch until weaning. This chart shows what whole milk actually provides in the designated minerals, and it also shows what NRC requires of these different minerals, and the percentage that's delivered in whole milk is obviously in the right-hand column. So as you can see, selenium provided by whole milk is going to be high, is just what the calf needs at 107%. So the difference between 0.14 milligrams compared to NRC of 0.13. That likely is because the adult animals, the mother of these calves, really is likely supplemented with selenium in their feed or even possibly by injections. But when we look at something like iron or copper, those are obviously very deficient, as well as manganese, with only less than 1% that's delivered in the whole milk. So it's a good idea for feeding whole milk to look at these trace minerals and see what we can do to supplement the calf. Likewise, in our discussion about trace minerals, vitamins do not necessarily provide all what's required by the calf if they're consuming only whole milk. An example would be vitamin E is only 16% versus vitamin A. Calf will get all the vitamin A they need from whole milk. So it's a good idea to review these different vitamin requirements and see what we can do about supplementing calves with additional vitamins if they're on a whole milk diet. Whole milk, unless it's handled properly, has got a high potential of delivering different types of diseases to baby calves. The most common examples we have are Johne's disease, mycoplasma, salmonella. There's high levels of E. coli that might be transmitted in the whole milk. There's antibiotics oftentimes in the waste milk, and we have to have ways to be able to store that waste milk and collect the waste milk, and that leads us to another whole area that storage could be contaminated, and we just have to make sure we've got all of these things in mind as we set about putting in a plan to feed whole milk to the calves on the operation. Johne's disease is a particular problem on some dairies, especially if it's endemic in the herd. The only way to be able to break the cycle of Johne's disease is to make sure that there's a very good pasteurization program in place for both the whole milk and for colostrum. This may be an opportunity for milk replacer and colostrum replacer as good options in a herd that is trying to eliminate Johne's disease. Same is true for bovine leukemia virus and other respiratory diseases as well. Another very common disease associated with dairy farms and in calf raising operations is diseases caused by Mycoplasma bovis. It can cause arthritis, it can cause inner ear infections or otitis, it can cause eye problems. Obviously in the lactating cow, mycomastitis is a real serious problem that needs to be dealt with. And then obviously pneumonia as well is a problem. So mycoplasma transmission within the milk and milk handling equipment can be a very serious problem. If you're going to feed waste milk, you have to pasteurize, particularly if you're feeding whole milk and a combination of waste milk. Anytime there's waste milk involved, pasteurization is a must. So what is pasteurization? Pasteurization is a well-established, long-time, good practice for making milk wholesome. It involves heat applied to the milk for a defined time and a defined temperature. So all of these types of definitions are put together by the Pasteurized Milk Ordinance, or the PMO. For whole milk, it's either a combination of 145 degrees Fahrenheit for 30 minutes, that's what we call a batch, 161 degrees for 15 seconds, that's typically what we call a high temperature short time. And then there's a couple different ultra short time, ultra high temperature types of pasteurization that we typically do not see on the calf ranch. 191 degrees for 1 second and 201 degrees Fahrenheit for 1/10 of a second. Those high temperature types of pasteurization are more for those types of milk that are stored without refrigeration. So those are all pasteurization times and temperatures for whole milk. For colostrum, it's a little bit different. Colostrum has to be kept at a temperature of 140 degrees for 60 minutes. Anything more than 140 degrees results in the potential denaturization of the protein and immunoglobulins that are within colostrum. So again, pasteurization reduces the bacterial count to manageable levels. It is not sterilization of the milk, however. The key point here is it reduces bacteria to a certain level that we can accept, but not sterilization. However, pasteurization does kill the bacteria that causes Johne's. There's a lot of disadvantages to pasteurization. Number one, that most significantly is the upfront cost. Any type of pasteurization system is going to involve significant investment by the calf ranch. Once it's set up and running, there's a fair amount of management that has to be done to make sure the pasteurizer continues to operate properly, that it cleans properly, and it's doing the job that it was intended to do. It takes a significant amount of management because you want to avoid pasteurizer failure. That can be something in a poorly managed type of operation. That could be something that's fairly common. Finally, pasteurization does not eliminate or decrease antibiotics in the milk. Antibiotic residues are still present in the face of pasteurization. There is a lot of information and a lot of research that's gone into looking at pasteurization in calf operations and what value pasteurization can have to the calf raiser. In one study, pasteurization saved a producer $8.13 per calf in gross margin over feeding the raw waste milk. Typically, in the past, pasteurizers were best suited for larger operations. Today, that's not true. There's a lot of pasteurizers that have been brought onto the market for herds as small as 50 to 100 cows. In this slide, it said operation size now about 200 cows due to low-cost equipment. That's probably in 2017. Like I mentioned, it's more like 100 cows, a 100-cow farm. So we've already talked about pasteurization is not sterilization. It's not a complete removal of the organisms, but it's a removal of the organisms down to a manageable level. So we have to always think about Johne's disease and diseases like that. If a Johne's disease organism manages to escape to pasteurization, that makes the management of Johne's eradication on the farm even more difficult. The one researcher in the United Kingdom found that Johne's was capable of surviving high temperature short time. Typically, however, on-farm batch systems destroys Johne's adequately. So Myco bovis, Myco californicum, they were killed after 70 degrees or 158 degrees Fahrenheit for 1 minute. So we just have to keep going back to this idea that batch pasteurization, 145 degrees Fahrenheit for 30 minutes and 161 and the high temperature short time for 15 seconds will be effective. So with pasteurized milk, we just have those added expenses with labor, equipment. We have to store that waste milk. We have to store it before pasteurization. Oftentimes we have to store it after pasteurization so we can fill bottles or buckets. And there's always those concerns that, is it being properly done? And do we have the adequate quality control on the farm? This is a picture of a gasoline type of a nozzle that's commonly used to deliver milk to bottles or buckets on a farm. This piece of equipment is very commonly difficult to clean, and as this picture shows, this nozzle was cleaned according to the protocol on the farm, but after taking it apart, you can see bits of milk residue within the internal mechanism of the feeding nozzle. There's many producers that buy waste milk from other farmers, and they'll typically pay around $3 a hundredweight for that waste milk. Then they take it home, they put it through their pasteurization system, and then get the value of that waste milk, assuming everything has been done properly. There's a significant capital investment in the hauling, storing, cooling, warming, pasteurizing of this type of waste milk. So the $3 per hundredweight is just the beginning of the cost of feeding that type of milk. We need to have significant labor requirements. We need to have people that are trained and competent to do this kind of work. And we also have to keep in mind with pasteurized waste milk, because of the high fat, we have that delay in weaning due to reduced starter intake with that high fat feeding of waste milk. So there's a cost there. There's a cost for extra facilities because of the delayed weaning. And there's ongoing maintenance needs, of course, with the pasteurizer and that type of equipment. So you take all those things in mind, and it is often a number that is heard in the industry that people have examined these costs, and it puts that management of waste milk cost typically around $9 a hundredweight. So you'd get an extra $6 a hundredweight over and above that $3 that it costs for the whole milk in order to get it to the point where it's delivered to the calf. So pasteurizers for milk, high temperature short time, 161 degrees for 15 seconds. Batch pasteurizers, 145 degrees Fahrenheit for 30 minutes. And then there's always the newer technology that's available of using ultraviolet light to pasteurize whole milk. This is generally thought of as a concern because the light does not penetrate whole milk very well. Bacteria can hide within the fat dropules. Bacteria may not get full exposure to the ultraviolet light. So it's generally regarded that milk pasteurization with the ultraviolet or UV light just is not quite as good as either a high temperature short time or batch pasteurization. And that's true of colostrum as well, where it's well established that batch pasteurization of colostrum at 140 degrees Fahrenheit for 60 minutes is the standard. There are several commercial brands of pasteurizers. Probably the most common high temperature short time unit is the Goodnature. The Goodnature machine was put together, originally sold for pasteurizing fruit juice. Calves, located in northeastern Wisconsin, has a very reputable machine. Dairy Tech there's actually two Dairy Techs. There's one in Colorado that sells a smaller machine, and then there's another one out in Washington State that sells a pasteurizer machine. Their Dairy Tech name is spelled slightly differently, but they are both companies to consider. The Goodnature pasteurizer was originally designed for juice pasteurization. It came out of Northeast U.S., very commonly found on large farms. It's set up to do a high temperature short time, so the milk flows through the unit fairly rapidly. They're fairly expensive, up around $25,000 and up. And they do need some additional heat source to complete the setup because it needs that high temperature on a continual basis. The Calf Star units will do anywhere from 3.5 to 30 gallons a minute. They've got a chart recorder on them that works very well. They can either be gas or an electric boiler. Very reliable type of machine, reputable company. Slide 25. This is Dairy Tech that's based out in Colorado. They've been around for a long time. The company was founded by a local veterinarian, and they have different types of machines that will handle typically smaller volumes of whole milk, and their machines will even pasteurize colostrum. The little hood type of thing shown in the upper right-hand corner of the slide is a picture of one of the original Dairy Tech pasteurizers, where that hood was placed inside a tank of milk and pasteurized the milk using that device. You don't see very many of those on farms anymore, but every once in a while you'll encounter one. So in review, there are a lot of issues related to waste milk, with the potential antibiotic residues as being one of the top ones. People have a lot of concern about resistance in pathogens to the antibiotic residues. There's also concern about tissue residues at slaughter because of the antibiotics that may be in waste milk. Feeding waste milk has to have a lot of planning to make sure that the storage plan is in place for the waste milk before pasteurization and after pasteurization. And finally, the waste milk consistency is something that the farm has to be prepared to deal with. As we've talked about, there's quite a variation in solids and protein and fat levels in waste milk because of the waste milk can be made up of fresh cow milk, transition milk, or mastitis milk, or milk that from cows that were treated with antibiotics. So before a farm goes out and buys a pasteurizer, they should think about all of the different issues that they have to consider. Equipment expense, labor expense, potential for residues. They have to figure out their storage from milk coming in and milk going out. Do they have the right kind of people and management in place to take care of a pasteurization system? Is there a huge biosecurity problem on the dairy with disease? How about mastitis? We think about mycomastitis as an example, or Staph aureus mastitis coming from transmission from the calf to the immature udder of the calf. And then we've already discussed nutritional consistency, the pitfalls of pooling all this milk together, going to the entire calf herd then. And we've always got the issues around making sure things get clean and that they're sanitized properly. The risk here really is if this pasteurization protocol is missed one time, it puts all the calves on the farm at risk. Every calf could become infected if the pasteurizer misses the cleaning that it needed to do on milk that was full of myco, for example, or full of iones. It's a high risk area for the farm. This flow chart is one that is kind of hard to read. On the left, and it's by design, on the left you have hungry calves, you feed a milk replacer, you determine your feeding goal, you buy the powder, you weigh it, you measure it, you mix it, you feed it, and then you clean up your equipment. On waste milk, there's a whole much longer cascade of chores to do to make sure that waste milk feeding is going to be correct for your calves. So the point of this whole chart is feeding waste milk or whole milk is a lot more complicated. There's a lot more things that you have to check, and it just puts a much higher level of management challenge to a calf raising operation.
Thank you for completing this Calf Academy course. If you have follow-up questions, please contact your Milk Products National Account Manager